In this video I'm going to explain to you how to derive the equation n1 sine I equals n2 sine r. During this derivation I will refer to the diagram that's on the screen around here, and that's to talk about that diagram. So what we've got is that we've got an incident ray coming through a substance of refractive index n1. That's going into a more dense material because the angle of refraction is greater than the angle of incidence, and the more dense material has got a refractive index of n2. We've got the angle of incidence I and the angle of refraction r. So using the equation that we learnt in the last derivation video that I did, we've got sine I, let me just get the pen on, over sine r is going to equal c1, which is the refractive index or the speed in the material on this side, over c2, which is the speed of the light in this material here. Now I would like to rearrange that equation so that I get the two terms donated to one side on the equation. So for example, I would like to get my I and my 1's together. I'd also like to get my R and my 2 together, because those both refer to the same side of the boundary. So to do that, I'm going to divide by C1 and multiply by CR. So first I'll divide by C1, so I've got sine I over C1 sine R equals 1 over C2. That will give me the equation sine I over C1 equals sine R over C2. And that's after I've multiplied through by sine R. So continuing from where I left off, I've got sine I over C1 is equal to sine R over C2. What I would like to do now is I'd like to multiply through on both sides of the equation by the speed of light in a vacuum. So I'm going to get C, I'm going to put it over C1, I'm going to put sine I there, equals C over C2 sine R. Now, from the previous equation as well, we worked out that the expression, which I'm just going to put in blue down at the bottom here, ns equals C over Cs, which basically means that C over C1 is the refractive index n1. So I can replace that with n1 sine I, and C over C2 is the refractive index n2. That's sine R. And so therefore I've derived the equation that n1 sine I equals n2 sine R, and that's known as the law of refraction.